Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the functional groups and carbon skeleton. The structure shows a terminal alkyne, CC, at one end and a double bond, C is equal to C, elsewhere, with 5 carbons total. Reading from the structure, C1C2, C3 is equal to C4, C5, H3, giving pent-3-en-1 as the base name. Step 2. Number the chain. IUPAC rules require giving the principal characteristic group, alkyne, the lowest possible locant. Numbering from the alkyne end, C1C2, then C3 is equal to C4, then C5. This gives pent-3-en-1, alkyne at C1 double bond at C3. Step 3. Determine the geometry of the double bond. The double bond is between C3 and C4. C3 bears H and C2, part of the alkyne chain. C4 bears H and C5, methyl. Looking at the drawn structure, the 2 hydrogen atoms, or the 2 higher priority groups, are on the same side of the double bond. The chain bends toward the same face, indicating Z, CIS, geometry. Using CIP priority, on C3, CCH, H, on C4, CH3, H. In the drawn structure, both higher priority groups, the alkyne side and the methyl side, are on the same side of the double bond, confirming Z configuration. Step 4. Assemble the full name. Combining 3Z, pent-3-en-1. Step 5. Why not E? If the groups were on opposite sides of the double bond, it would be 3E, pent-3-en-1. The drawn wedge line geometry shows a Z-CIS arrangement. Therefore, the correct answer is 3Z, pent-3-en-1. The correct answer is shown on screen.